we have our knife disassembled, and so now I'm ready to start building some parts. Now, I got to thinking about it, and I'm not going to start with some of the larger, maybe easier things such as the liner or the blades. I'm going to start with the smaller parts that would be potentially more difficult to recreate, because if I can't recreate those, there's no point in going down the road of making the bigger parts and then trying to get to the small parts when the time's ready. And the first thing I thought I would start with is the springs. So this knife has 3 springs. It has what I'm going to call the leaf spring, which is the spring that throws the blade. And then it has the button return spring. And then it has the safety, which has a spring. It's kind of like folded over, so it's a spring built into it. And so that's what I'm going to try to start with. Now, the first thing is the leaf spring. The leaf spring, I thought, okay, well, this is going to be easy. I'll just go online and I'll be able to find some spring material in the proper thickness and width that I need. Easy peasy. The hardest part will just be bending it properly. But that's proved to be a futile effort. I could not find in the thickness and width that I need. So I'm going to have to make it. And I got to looking around on some different websites about making springs and using, looking for thin material that I could buy. I mean, I know I could make a spring out of CPM 154. That'd be awesome. But getting a spring that thin, and you can't buy CPM 154 that thin, I've got to find something else. And I'm wanting to go with all stainless on this knife as well. I don't want to use carbon steel if I don't have to. So after doing some reading, I found that some people make springs out of 410 stainless. Now, I don't know how well this is going to work for the leaf spring. I think it'll work fine for the button return spring. I think it'll work fine for the safety spring. Not so sure about the leaf spring, but this is where I'm going to start. And so my effort here is not to build the leaf spring at this point, but to cut up in little strips some 410 stainless, do some heat treating and do some testing to see if this is going to be a suitable steel for my springs. And so I have various sizes of 410. That's kind of the reason I went with it as well, because I've got anywhere from 0.024 up to 0.060. So I've got various sizes that I can experiment with. And so that's what I'm going to do at this point. We're going to cut some strips, heat treat those strips, and see what kind of spring temper they get and how well they'll hold their form. I want to check the thickness on these springs to see what we're dealing with. And I did this one last night, so I already know what it is as I was trying to find it online. But we'll just go ahead and test it again. So we're in inches here. And so we got 0.029. And we'll just check it throughout the spring. 0.29. 0.285, 0.29, 0.29. So we got 0.29 on our thickness. I've got some 410 that's 0.024, which will be too thin, and some that's 0.032, which will only be 0.003 over. So that's what we're going to use for this spring. Now on the width, let's see, let me get it this way where we can kind of get it in there. So we're looking at 0.0785. So that's about how thick I want to make it when I cut it out, these little strips. So let's check these other ones. So on the button return spring, let's see what we're looking at. We're looking at 0.19 right there. 0.19. So I'll go with the 0.024. It'll be 0.005 over, but that'll be all right. This is not as critical. And then for the little safety, so this is a spring as well. So we're looking at on that 0.0195. So basically 0.02. So we'll use the 0.024 stainless for this one as well. Now it occurred to me that when I measured the width of this spring, so it's 0.079, that's not really the true width that I need to make my spring. So I need to make my spring proportional to the thickness of the back piece. And so let's see, for instance, here's the back piece. So let's measure this. So that's 0.093. So that's right at 3/32, 0.935. And this, again, is 0.785. So this is 15 thousandths thinner than my back piece. Now on my knives, I'm probably going to be using, by the time it's cleaned up and everything, my back piece and my blade tangs and stuff are probably going to be right around 0.100. And so based on that, when I do the width of my spring, I'm going to want to do my width to be 0.085. And so that's what I'm going to try to do. I'm going to try to do my spring 0.085 in width. I'm over here at my mill, and I've got a piece of 0.032 stainless, 410 stainless clamped down. And I've got a 16th inch cutter in. And what my goal here to do is to cut out a series of strips that I can heat treat and temper to try to determine whether or not this is going to work well for spring material. Now, I don't want to just cut out a whole bunch of individual strips and have to deal with trying to heat treat each one of them. So what I'm going to do is I'm going to make a series of cuts at the proper width apart so that when I get finished, it's still going to be connected down here, it's still going to be connected over here, but it's just going to be a bunch of lines. Once I get that cleaned up, then I can heat treat this one piece. I can wrap it in stainless. I can heat treat the one piece. I can put it between aluminum blocks to quench it. And then I can, if it's hard enough, I can just break these ends off and have a bunch of individual springs. And so that's kind of my idea here. So we're going to come on down. Let me get my mill turned on. And we'll get this in the general proximity. All right. I've got a little bit of a 3-in-1 oil here that I'm going to put on there. Let me just make sure that that's in, yeah, you can still see that. So let me get it out. And I'm just going to do as many of these little pieces as I can, because I'll be doing different heat treats and different tempers. Well, actually, I guess just one hardening process, but different tempers on multiple pieces to see what's going to work. Because I think I'm going to have a stronger spring, of course, for the blades than I am going to have for the button return and that kind of stuff. So now I'm running my mill at, I think, about 3,500. Put a little oil through there, just in its path. And I'm using my auto feed, and I'm just going to let it go down there and do what it's going to do. So anyway, I'm not going to film the whole thing. You'll see me starting to make a cut, and I'll cut the camera, and then I'll pick back up after the cut's finished. So let's get this thing going. I'm going to touch off. I'm going to turn it on, then I'm going to touch off, zero out my RDO, and then I'm going to go down about 40 down into there. All right, touched off. I'm going to zero out. All right, I'm through my material. So I'm going to engage my, I'm going to start it off really slow though. And I'm just going to let that run. All right, so now I'm going to go in for my second cut. And with this one, I could cut coming back this direction, but I don't really want to. I'm going to go back all the way over to this other side, and then I'm going to come back that way. So. All right, and I need to go in. I need to go in 0.148. And I know it's 0.148 because I want this each of these pieces to be 0.085 thick. And then so I add that to the diameter of my cutter, and it comes to 0.148. So it's 0.148 right there. And so let's get this going and do our next pass. I'm just lowering it to my cutting depth. And then I'm going to engage the auto feed. I've finished my second pass, and it's kind of hard to see, I know, because of all the chips. And also, this is a very rough edge on here. So once I get this fully cut, then I'll flat sand this and get it down, and then it'll look a lot better after that. But I'll probably gonna hit this with my vacuum, pick up the loose chips, and I'm just gonna keep doing what I was just doing all the way until I get at least most of this piece slotted up. It took a while, but I have all of my slots in this piece, and I think I'm gonna have about 15 strips to work with. So let me get this out and cleaned up, and we'll take another look at it. Here's my piece of 410 after cutting the slots. And so you can see it left me a good number of strips. And as I mentioned, the thought is to keep this together so that I can just heat treat it as one piece, harden it as one piece. And then with it hardened, I should be able to just to bend this back right off here and snap it off. And when I temper it, I'm going to temper it several of these different ways to try to figure out which temperature works best for tempering, because I'm going to need 3 different kinds of temper. So I'm going to need something a little harder for this. And when it comes to remaking this, I don't think I'm going to be able to get the strength that I need and also be able to bend it to form. So that means on some of them, for building this one anyway, I'm probably going to have to bend it to form and then heat treat it. And for that reason, I'm probably going to go ahead and maybe cut 5 or 6 of these, split them off, and hold those out and not harden these yet, but save them for later, because it is going to be the right thickness and width for the spring that I'm going to use. But then for this spring, I really don't need anything as strong. I just need a spring that I can, or a temper that I can bend. So I don't even have to bend it all that much. You see, there's not a whole lot of bend to it. It just comes up just a little bit. And then I'm going to want a really softer temper for this, because what I'd like to do is I'd like to temper it straight and then bend it and crimp it and hope it still has enough spring left in it just to do that right there. But I don't know if that's possible or not. So that's some of the things that I'm going to experiment with these different strips and see what I'll be able to do. So from here, I'm going to heat treat this. So I don't think I'll film it, I'll just tell you. I'm going to cut about right here, save me 5 or 6 of these. And the rest of it I'm going to put in a foil pack, and I'm going to heat treat at about 1825 for about 15 minutes. And then I'm going to come out and put it between my aluminum quench plates. And then when it cools, we'll open up the packet. We'll see how hard everything is. This is the piece that I left out of the heat treating, and this is the packet that just came out of the heat treat. So I'm going to open this up and see how it turned out. All right, yeah, it looks pretty good. Let's run a file across it. Yeah, it's just skating across there. I took some Rockwell hardness tests on this, and you might can see the little indentions through here. It came out to be right at 47 hardness, and it was consistent at that. And so like for a normal spring, particularly something thicker, 47, 49, that would be a good spring hardness for like CPM 154 or even O1 carbon steel. I'm not sure how it's going to be on this. This does seem pretty hard, but I'm going to put this in the vise and we're going to see if we can snap this end off. Actually, let's snap this end off since it's a little discolored. Not that it matters, but just get it clamped down where I can just barely see my little ends coming out there. And let's see if it's going to snap off. Yep. So that broke right off. So even though that's 47 hardness, you can pluck these things and you can feel the vibrations in there. That's kind of neat. But anyway, it's still pretty hard. So the next thing I want to do is I'm going to go temper this. I think I'm going to temper it for an hour and a half because it's pretty thin at 625. And then we'll break off a couple of these pieces and see what kind of properties they have. Here's the set of springs after they've come out of tempering. And I tempered for an hour and a half at 625. I did some more hardness tests and it's coming out at about 41. And remember when it was fully hardened, it was about 47. And so we're gonna test this. And it's definitely springy because I can pluck one end like that, and I don't know if you can see it vibrating, but I can feel it all the way down in this other end. So it's definitely springy. But let's get a couple of pliers here, and we're going to do I think I'm going to turn around and do it on this small one right here. So we're going to do just kind of a break or a bend test to see what happens. All right, I'm going to do it fairly quick, assuming it's going to snap. Yeah, did you hear it though? All right. All right, so it snapped off. I want to see how easy it is to snap, and then if we can bend it without snapping. So make sure this is still in frame. So let me just tell you what, I'll do it this way. And I'm just going to do a kind of a slow bend. I can hear it starting to crackle a little, which tells me it may be about to break. So that's not too bad right there. I'm just going to quick bend it the other way and see what happens. Well, that's not too bad either. If I do a tight bend, bend it back, it snaps. So that's actually pretty good. Let me measure out 1 inch of this because that's the length of this piece. We're going to measure out one inch of it and see if we can match its bend. All right, I'm just going to snap it off right there. All right, so that's actually a little bit shorter, but let me just see what kind of bend I can put in it. Just trying to put a little bit of a curve to it. Here's what I have set up. I've got a C-clamp in my vise, and I've got the original button return spring clamped on one side and my test piece on the other side. Now I want to point out a couple of things. One is on the camera this looks like it's a lot lower than this one. It may be slightly lower, but I think the camera's kind of playing a trick, because one thing is this is 20 thousandths thickness and this is 32 thousandths, and so They're pretty even across the top. This one drops down lower because it's thicker. When we remake this button spring, I'll be making it out of 24 thousandths because that's what I have, instead of this 32 thousandths. But the 32 thousandths was what we were testing with when I cut all those strips. So I got it in here so I can take another piece of steel and just basically push those all the way down to the floor and see how they return. I'll do that a few times. And so you can't really see it on the camera, but if I get down to the side and look, they're pretty much in the same place that they were. I mean, again, this one is just a little bit lower, but I can compensate for that when I make the actual spring. And you may, if you hear the printer, I got my 3D printer running in the background. I'm making a template for cutting out this spring, so it'll match in its size and shape. And then also for the safety spring. So that's what's going on in the background. But I think if I make the spring out of 0.024 or 24 thousandths instead of this, 32 thousandths, I think I'll be able to put a little more form in it, and I really think it's going to work well. So you hear those things.